In this lesson, we will be factoring trinomials that start with a lead coefficient of 1. When a trinomial starts with the number 1, or you see a trinomial that has an x squared without a number in front, that implies there's a number 1 in front of the trinomial. And we can use what I refer to as a factor pair shortcut to factor the trinomial, where we don't exactly have to go through the entire grouping process like we did on the previous lesson. The steps to factoring a trinomial with a lead coefficient of 1 require us to take the number 1, which would be in the A position, and multiply it with C together so that we can find the factor pair that adds to B, which is the coefficient of the middle term. This is very similar to factoring by grouping for trinomials, but we'll always have a 1 as the first coefficient for x squared. What we do for this particular type of factorization is we don't have to rewrite the middle term for two terms and group factor. We instead can quickly factor by rewriting two binomials where x squared is made up of x and x, or x times x, and then the factor pair that we end up with ends up going into the two positions as you see written into these binomials. If a factor pair doesn't exist, that actually tells us our trinomial is non-factorable or a prime polynomial, which just means it doesn't break apart. Kind of like the number 7 doesn't break apart. The number 6, for instance, is 2 times 3, but 7 doesn't break apart without having to use the number 1. So we say it's prime or a prime number. So let's factor using the factor pair shortcut on the example x squared plus 5x plus 6. If I were to do this, I would take this invisible 1 and multiply it times 6. So 1 times 6 is 6, or you could just start with 6. And we're looking for a factor pair that adds for 5. So we have 1 and 6, 2 and 3, and you can see there that 2 and 3 actually give us the factor pair we need. So as far as factoring goes, this is a very quick process. We're going to set up two binomials. And for x squared, I'm going to say x and x. If that were y squared, I'd say y and y. And then I have my factor pairs. Positive 2, I'm going to use plus 2 for positive 2. And then positive 3, I'm going to use plus 3 for positive 3. Notice that was a lot faster than factoring by grouping. And it will be, if you can find a factor pair that works for your trinomial, and your trinomial starts with a 1. It'll actually be that quick. If you were to multiply x plus 2 and x plus 3, you would find that you get x squared plus 5x plus 6 back, and that tells us that those are the correct factors. So what if we were going to compare that to factoring by grouping, which is what we had been doing? We should get the same answer if we do factoring by grouping. So if I were to take 1 times 6 and get 6, still looking for a factor pair that works here, which happens to be 2 and 3 again. Remember how the grouping process works. We're going to take our trinomial and rewrite it so that it becomes x squared plus 2x plus 3x plus 6. Then we're going to factor in groups of 2. In the first two, you see x and x plus 2. And then in the second two, you see 3 and x plus 2. And eventually you factor out x plus 2, and then you also have x plus 3 as the other factor, or x plus 3, x plus 2. What I want you to notice is that the answer here and here, this and this, are identical. So whether you factor by grouping, which is the previous lesson, or you factor using what I call the factor pair shortcut, you will get the same answer. The nice thing to know is that you can use the shortcut when the trinomial starts with a 1 and when you can find a factor pair. So let's just look at quite a few examples, factor the trinomials. In the first example there, x squared plus 8x plus 12, notice that we're starting with a 1, so we can use our little shortcut if we can find a pair. So we're going to say 1 times 12, which is 12. And we're looking for a factor pair that will multiply for 12 and add for 8. So I start my pair, 1 and 12, 2 and 6, and 3 and 4 is a pair, but I already noticed that 2 and 6 work. So for the factorization of this, I am going to write two binomials. For x squared, I'm going to say x times x, and then I'm going to use my factor pair, positive 2 and positive 6, and it's actually been factored. So let's take a look at the second example on row 1. I have a trinomial that starts with a 1, and so I'm going to say 1 times 2 equals 2. And when I do my factor pairs, I get 1 and 2, but I don't really have another 1 in that column. But remember, you can always do the change of signs, and that's actually going to add to -3, which is what we need for the factor pair that adds to b. So I found a factor pair. My trinomial begins with a 1, which means this is a factor pair shortcut. Y squared, y times y gives me y squared. So it's not x's this time, it's y's. And then I have a -1, so I'm going to say -1 and a -2 and then -2. And then that completes the factorization for that trinomial. As I move to the second row, I notice again a trinomial starting with a 1, and this time I have -54. So 1 times -54 will give me -54. And I am looking for factor pairs that add to -3. So let me start with -1 and 54. -2 goes in 27 times. -3 goes in, what, 18 times? -6 goes in 9 times. If I take -6 and 9 and add them, I get 3, but I'm looking for -3. So I'm going to try switching the signs and see if that works, and it does. 6 and -9. That adds to -3. So I'm ready to factor. I'll set up 2 binomials. X squared, I need x and x for x squared. And then a +6 and a -9, because that was the sign that each of them had on the factor pair. So next, we're going to look at a squared plus 4a minus 12. A trinomial that starts with a 1 tells me I might be able to use this shortcut if I can find a factor pair. 1 times -12 is -12. When I run the factor pairs, I'll say -1 and 12, -2 and 6, -3 and 4, and I could go on, but I already see here that -2 adds for 6 to give me +4. So that's going to be the factor pair I need. So I'm going to set up 2 binomials. For a squared, I'm going to use a and a. And then I have -2 or -2, and then +6 or a +6. So these would be the factors of a squared plus 4a minus 12. As I move to row 3, I see I have a trinomial again that starts with a 1. And then I'm going to say 1 times -20. 1 times -20 is -20, -1 and 20, -2 and 10, -4 and 5. And I'm looking back for B. I don't see it visibly, so I'm going to put a 1 in there. So I'm really trying to add to -1. What I notice is I have -4 plus 5, which is 1. I need -1. So let me see if I switch the signs. And that does it. 4 plus -5 is -1. This tells me I'm able to factor with my factor pair shortcut because I found the pair and my trinomial starts with a 1. So x squared is going to take x and x here, and then we're going to say +4 and then -5. In the second example in that row, I have a trinomial that starts with a 1. So let's start our process. 1 times 6 is 6. My factor pair is 1 and 6, 2 and 3, -1 and -6, -2 and -3. None of those are all the pairs. None of them add to 4. What that tells me is my trinomial does not factor apart. It's like a prime number. So sometimes we'll say that our polynomial or trinomial is prime. It doesn't break. Sometimes we'll say it's non-factorable or unfactorable. It's really it really just depends. You could say either one of those. So if it doesn't break apart, it just doesn't break apart. In the next example, I have a squared minus 9ab plus 18b squared. Even though I see two variables in there, I notice my trinomial starts with a 1. So I'm going to say 1 times 18 is 18, and I'm looking for the pair that adds to -9. So 1 and 18, 2 and 9, 3 and 6. 3 plus 6 is 9. I'm almost there. Let's see if I change the signs. Yes. So that is going to multiply to 18 and add to -9. So when I set up the binomials on this one, what's a little different is I have two different variables, a squared, b squared. For the a squared, I'll do what I did on the previous ones and put a in each one of those positions. And then b squared with 18b squared, it's kind of simple. You just put a b times b is b squared, and you're going to attach the factor pairs to the front of those b's. So I have -3, so that's going to give me a -3b, and then -6 will give me a -6b. Now this does mathematically work out if you were to distribute, just to show you what this looks like. A times a is a squared. A times -6b would be -6ab. -3b times a is -3ab. And then -3b times -6b would be positive 18b squared. Notice we have a squared, and then this adds up to -9ab, and then 18b squared. So that does equal back to our original polynomial. So if you have an additional variable, you just include it in the shortcut for the factorization. So let's take a look at this last example. Again, two variables, but I'm not nervous about it. I have a 1 starting, so that tells me I might be able to use a shortcut if I can find a factor pair. So 1 times -12 is -12. -1 and 12, -2 and 6, -3 and 4. And what is my b value? I don't see one, so I'm going to call it a 1. I'm looking for +1. -3 and +4 adds to +1. So that tells me I have a factor pair that works. So it does factor. And then I'm going to break into two binomials. I see x squared and y squared. Remember the trick. X and x for x squared. Y and y for y squared. And then as far as the factor pairs, that's going to go with the y. So it's -3y and then +4y. So moving on, here's a question. Can I correctly use the factor pair shortcut on all trinomials? So the question here is all trinomials. And the answer is no, only if the lead coefficient is a 1. So if I look in this example, just to see here, could this be used? I could use it if I can find a factor pair. So this is a yes. In this one, no, I can't, because it doesn't start with a 1. And in this one, yes, I can, because it starts with a 1. Even though there's an x squared and a y squared, it doesn't matter as long as that 1 is there. So here's a big question. What do I do if I can't use this shortcut? Then you have to go back to factoring by grouping, which is what we learned in the last lesson. And so it starts the same. You multiply these two numbers together. You get, in this case, 12. Since I don't have a 1, once I get my factor pairs set, which would be 3 and 4, I would have to rewrite the problem into factoring by grouping. So that's that process where we would take our middle term and say 3x plus 4x replaces the middle term, and then we're going to group to factor. So we would say 3x and x plus 1. And then here is 4 and x plus 1, where we eventually end up with x plus 1 and 3x plus 4. And if you multiplied that back, you would get 3x squared plus 7x plus 4. So you can see there that it is a different process. If you do not start with a 1, you need to do that factoring by grouping.